Hello everyone, my name is Dmitry Sentilovich and I'm the COO of Dexmat.
Hello, my name is Francesca Muri and I'm the CTO of Dexmat. And today I'm going to talk to you about our novel technology to produce lightweight carbon nanotube fibers for aerospace applications. But first, let me set the stage here. In 1961, there were about 100 satellites around the Earth. Today, 50 years from then, there are thousands and thousands of satellites around the Earth, and many more are expected to be sent to space in the next 10 years. So, how much does it cost to send a satellite to space? Well, it turns out it's quite expensive. It's about $10,000 per pound, with an overall launch cost of $50 million per satellite. If we could use a lighter wiring material, we could save up to 300 pounds. This is a dramatic improvement in payload and is absolutely critical for satellite companies. Weight is not a problem just for satellites. It's a problem also for aircrafts. For example, in an Airbus A380, there are 330 miles of metal wires and cables. If we could substitute the metal components in these wires and cables, we could save more than 7,000 pounds. This will not just increase travel range and payload. This would also reduce emission and save money for fuel. The global market for wire and cables for aerospace applications is $12.7 billion. And most of these cables are made out of metals. They're heavy and they wear out due to poor flex fatigue. So there is a need for a material that is durable, lightweight, and conductive. Our product is carbon nanotube fibers. These fibers are as conductive as metals. They're 10 times stronger than copper. They're 25 times more flexible than copper, but with just 1/6 of the weight. We produce these carbon nanotube fibers with a patented dissolution technology from Rice University. We buy carbon nanotube powder from any manufacturers in the United States or abroad, and the price of this material has decreased a lot in the last 10 years, and it's expected to reach 50 cents per gram in 2020. We then mix this carbon nanotube powder with a commodity acid, chlorosulfonic acid, and this acid has been used for decades in the polymer industry. These two ingredients together make a carbon nanotube solution. We use this carbon nanotube solution to make our fibers by extruding the solution through tiny holes, as you can see from the video. While the solution is coming out from the holes, we remove the acid and we're left with a solid carbon nanotube fiber. This process is very similar to what is currently used in industry right now to produce Kevlar fibers. And we spend about $20 million in research and development at Rice University. Due to the outstanding properties that we were able to achieve, we got a lot of attention from the media. We've been featured in local journals like the Houston Chronicle, MIT Technology Review, as well as NBC News. NBC News had an article about how our carbon nanotube fibers could potentially be used one day to make a space elevator. Our technology is based on 4 patents from Rice University, and we're the inventors on those patents. We're currently negotiating a license for all those 4 patents, 2 exclusively and 2 non-exclusively, with the help of our legal consultant. Also, we just received the initial term sheet from Rice, and we're currently reviewing their offer. Today, we can produce more than 1,500 feet of continuous carbon nanotube fibers daily in our lab. We were also successful in producing all carbon nanotube cables that met the military standards for transmission. Also, we got a purchase order from NASA for $25,000 and letter of intents from our customers. They're ready to test our fibers in their facility. Now, the reason why these customers are so interested in our product is because carbon nanotube fibers have properties that no other material on the market can offer. The main properties for wiring materials are conductivity, lightweight, flexibility, and strength. Copper can deliver just on conductivity. Composite materials are lacking in flexibility and strength. Fiber optics has poor flexibility that limits its use. Carbon nanotube fibers are the only material that can deliver on all of these properties. Now, it turns out that there is just one company on the market that can produce carbon nanotube fibers, and this company is NanoComp. Their fibers and our fibers are similar in lightweight, flexibility, and strength. However, our fibers are more conductive, they're produced in a cheaper way, and also our process is more scalable for high-volume manufacturing. The reason why our process is more scalable and cheaper is because it's based on a fluid phase processing, whereas their process is a solid phase processing technique, and that is inherently less scalable. And now I'm going to pass the presentation over to my colleague Dimitri that will tell you about the market.
Our go-to-market strategy will have Dexmat fully focused on fiber production. We will set up a pilot plant capable of a relatively small amount of volume manufacturing, and the capacity of this plant will be 150 miles of fiber annually. Now, the quality of the fiber that we produce with this plant will be commercial quality, and we will sell this fiber to cable manufacturers. The cable manufacturers will assemble our fibers into finished cable products by putting on connectors and insulating the wires. And we have an established relationship with two cable manufacturers, TE Connectivity and Minnesota Wire, and they've already tested our fibers in their facilities and are happy with the performance. Both these companies have told us that they are ready and willing to buy our product when it is commercially available. The cable manufacturers will sell the finished cable assemblies to the end users, which are satellite manufacturing and aircraft manufacturing companies. And the cable manufacturers have an established partnership with these companies and will be the ones marketing the cables to the end users. Dexmat's marketing strategy will be to acquire more customers who are cable manufacturers for our wiring products. Our target market initially will be satellite wiring. And the reason this is an excellent entry point for Dexmat fibers is because in the satellite industry, our fibers will have a rapid adoption. And we know that carbon nanotube materials have been put into space flight in under 6 months. In addition, in space, weight is money. And satellite companies are willing to pay a premium price for a lightweight wire. In fact, from conversations with cable manufacturers as well as satellite companies like Northrop Grumman, we know that we can charge at least $45 per foot of our fiber. And this is the baseline price. And why are they willing to spend so much money on a wire? Well, the reason is if they replace their copper wiring with our wire, even at the higher cost, they still end up saving more than $500,000 in launch costs. Now, over time, as we increase our production volumes and decrease the cost of our production, we will be able to set a price point that will also enable our fibers to be incorporated into cables for military aircraft and eventually also commercial aircraft. However, for the first 4 years of operation, we'll be fully focused on making our fibers specifically for wiring in satellite markets. Now, the total amount of wire used every year in satellite market is 20 million feet of copper wire. And at a price point of $1 per foot, this is a $20 million market. However, at our price point of $45 per foot, for Dexmat, this becomes a total addressable market of $900 million. Based on this $45 per foot price point, you can see that we'll initially start generating revenues in 2016 when we set up our pilot plant. We'll gradually increase the production capacity in our plant to ensure that we're delivering consistent product quality and maximizing the yield in our process. And you can see that by 2018, we will break even with $6.5 million in revenue. And in 2019, we'll run our pilot plant nearly at full capacity, produce 125 miles of fiber, and make $14.7 million in revenue. Now, our cost of goods sold is shown by the blue bar here. And you can see that in 2018 and 2019, we'll be operating at over 80% profit margins, gross margins. Now, this also serves as an excellent opportunity for Dexmat to be acquired by one of the cable manufacturers we're working with, or by a large chemical company. However, if we're not acquired at this point, we are ready to continue to expand our production and grow our company. The funding that we require to become a commercially profitable entity is a $2 million seed capital investment round. The majority of this funding will go towards funding the design and installation of our pilot plant. And this will fit into a 2,500 square foot facility, and it will be designed and installed by Hills, which is a company that specializes in making equipment for the fiber industry. The rest of our funding will go towards labor, raw materials, and facilities, as well as management and marketing, and patent licensing and legal fees, all the way to the end of 2016. While we'll be fully focused on the satellite wiring market initially, we realize that there's huge potential opportunities to expand our fibers into other markets. And one market we expect to expand into is going to be wiring in commercial and military aircraft. And we also see opportunities in the medical cable market for our wires, as well as in the rapidly growing wearable electronics market. And in wearable electronics, one particularly intriguing application of our fibers is going to be in smart clothing. And just imagine what you can do with a conductive thread. You can sew electronics directly into your clothing that are able to monitor your vital signs and even change the color of your clothing at a whim. Now, this is a commercial from Under Armour. And you can see they've already imagined this type of technology. Dexmat's vision is that our fibers are going to be the material that enables this kind of technology to actually be developed in the future. Our team has the world's leading experts in processing carbon nanotube fibers. Myself and Francesca are PhD candidates in the chemical engineering program here at Rice University, and we both spent the past 6 years developing and working on this carbon nanotube fiber technology. We'll be graduating in the next few months and joining Dexmat full-time. We're also joined by Dr. Matteo Pasquali, who's a professor of chemical engineering here at Rice University, and he's continuing the work of the late Rick Smalley. Dr. Pasquali is a worldwide authority on carbon nanotubes. Our CEO is Dr. Alberto Goenaga. Alberto has more than 20 years of industrial manufacturing experience, and he's led efforts in scale-up of extrusion processes and also has lots of experience in product development and quality control. Alberto was also recently a technical leader in 2 startups that have had successful exits. In addition, we are looking to hire a CEO in mid to late 2016 when we finish setting up our pilot plant. We're looking for someone with a strong marketing background who has startup management experience. Now, as for our advisory board, you can see that not all of them like to wear suits, but all of them have the right experience to make Dexmat into a successful company. Stephen Mays is a serial entrepreneur and private investor who helps us with his entrepreneurship and management experience. George Slensky is the former principal technologist at the Air Force who specializes in conductive wiring technology. And Dr. Glenn Irvin is the president and COO of Unidyme, which is an established carbon nanotube manufacturing company. And Glenn Irvin brings his experience in industrial manufacturing to the table. In summary, Dexmat has a disruptive platform technology for making carbon nanotube fibers that are going to be used for designing strong, lightweight cables. We are going to be making the next generation of conductive materials, and we have a $0.9 billion addressable market in satellite wiring and $17 billion of potential market opportunities for growth. We have aerospace customers that are on board and ready to buy our product. We have the right team of carbon nanotube processing experts and industrial manufacturing leadership to bring our technology to the market. We are Dexmat, and we are rewiring the future.